Well, hello everybody. Welcome back. So yesterday, or last time, well, I recorded this yesterday, but I don't know whenever we watch this, but last time we were left with an equation where all the x's went away and we had this true statement. Well, that's a special type of equation, and today we're going to get into classifying those type of equations. There's three types of equations to classify. So we have, when we're solving, and we really can't determine till the end of the process when we're solving, but we have what's called a contradiction. If it's a contradiction, there's not going to be a solution. And the way that you know that it's a contradiction is at the end, when you're done solving, you get a false statement. A false statement is something that, like when you have numbers involved, it's like 2 equals 6 or 0 equals 5. Well, that's false. That's not true. And all the x's are going to go away. You're not going to be able to solve for x. So in that case, it's going to be a contradiction. The next type of equation that we'll run into is called an identity. An identity is an infinite, has infinite solutions. And when you can tell it's an identity because when you're done solving all the steps of solving, at the end, all of the x's are going to go away, and you're going to be left with a true statement. All right. If you remember the very last example that we did last time, it ended up as a true statement. All the variables went away. That's an identity, and that means that there's going to be infinite solutions. So when you are solving these now in college algebra, not only will you have to be able to find x if there is an x, or find the solution if there is one, but you have to classify whether it's a contradiction, identity, or this last one we're going to talk about, conditional. When it's conditional, there's just one solution. The conditional is the typical case. When you solve, you get x equals a number. So in parentheses, I have here, the variable equals a number, okay? So three types: contradiction, identity, and conditional. I'm gonna give you a minute to write all that down. I need to make sure you have that written down so you can study over those terms. Now we're gonna practice solving some, and we're gonna classify. Okay, this is gonna be fun. I'm gonna erase. So for our first example, let's say I have x plus 3 equals x plus 5. We have those steps to help us solve any equation and avoid mistakes, but there's no distributing to do. This one's pretty simple. There's no fractions to clear, and there's no like terms on each side to combine. So we're already on the step of moving all the variables to one side. I'm going to choose to subtract this x from both sides, and if I do, well, both x's go away, and I'm left with 3 equals 5. And this isn't saying that x equals a number. We don't know what x equals because they all went away. So we're going to determine what kind of a statement is, and 3 equals 5 is not true. That's not true, at least in any world that I want to live in. And when we're left with a false statement like that, well, we can't find a solution for x, and we would say there is no solution. There's nothing that could make this true, and we would classify it as a contradiction. Okay? What do you think? Think about it. Look at this, the beginning of it. When we say x plus 3 and x plus 5, the right side will always be bigger than the left side. They could never be equal because whatever x is going to be the same on both sides, and you're adding a bigger number to it on the right side than you are on the left side. So I want you to be able to visualize that and see that there's no solution. Okay, false statement, no solution, contradiction, just like the song. Let's try another one. All right, for this next example, I have 2x plus 4 equals 2 times parenthesis x plus 2. So we'll follow our steps. I do have some distributing to do this time. So 2x plus 4 equals, when I distribute, 2x plus 4. Notice that once you get to this point, if you can recognize you have the same thing on the left as you do on the right, it's always going to be this case. But we would be to where we want to move all variables to one side. So I'm going to subtract 2x, and then I'm going to be left with 4 equals 4. All the x's went away again. I can't solve for a particular x. They all went away. But this one's different than the last example because this one is a true statement. And when it ends up being a true statement, there are infinite solutions. Okay? And when there are infinite solutions and it's a true statement, we classify this as an identity. Identity. Okay? All right. What do you think? Okay, moving on. I'm going to erase. Let's do one example that's going to lead to the other case, the only case we haven't had an example about. We're going to make it real simple. 2x plus 5 equals 15. Simple equation, but we're more concerned about classifying right now than solving a complex equation. But if we went through our entire process, we'd have no distribution, no fractions to clear, no like terms on each side to combine, and then no variables to move to one side. All the variables are already on the left. My first step would be to subtract 5, and I get 2x equals 10, divide by 2, and x equals 5. So in this case, we're left with x, or a variable equal to a number. This is my favorite, it's the most satisfying case, because you have a solution, you know what it is, right? When you have a solution, and a variable equal to a number, we classify this as conditional. Okay. So that wraps up 2.1. Thank you for listening to my lesson. If you liked everything, hit some likes, push subscribe. Isn't that what they say, the YouTubers? I don't know. But thank you very much, and I'll see you soon.